For this lesson, we're going to be looking at permutations and combinations. So to start, we're going to do a little bit of an introductory problem. And in this problem, we're going to be looking at some snap cubes. Now, of course, if we were in the classroom, you would actually have some snap cubes to use and to manipulate. And if you would like to try your best to recreate that experience, you can click this link here, or you can type it in if you just have the PDF, but you can click this link and you can actually move the cubes around. So as we go through this, if you need a little bit more of a visual, you can absolutely go and click this link and access the visual and play around with the cubes yourself. But for our purposes, we're just going to read through this and solve the problem together. But if you want to pause the video now, look at that link, you are encouraged to do so. Now for this particular problem, we have 8 of these snap cubes and all 8 are different colors. We want to snap all 8 of these cubes together in one long row. Now we have a few conditions here that we need to adhere to. The blue cube must be beside either the red cube or the green cube. And then we want to figure out how many ways we can arrange these 8 cubes so that the condition is met. So what we're going to do is we're going to have to look at this in terms of cases. Very often when we're looking at the number of ways something can happen, we need to break it down into cases in order to ensure that we've counted all of our different options and that we make sure we aren't double counting anything. And I'll explain what that means in a moment. So let's look at our first case here. So the first option we can have is that the blue cube's beside the red cube. So that's going to be case 1. So we'll have our blue cube beside our red cube. So in order to determine how many ways we can do this, I'm just going to draw some lines just to help us visualize the situation. So we have 8 cubes, so I'll draw 8 lines to represent these 8 cubes. 1, 2, 3, 4, 5, 6, 7, 8. Now we know we need blue and red together. So I'm just going to put blue and red right here. Red and then blue. They're beside each other there. Now we've already used up 2 of the cubes, right? Our red and blue ones are accounted for. So for this next spot, we have 6 possible cubes that could go there, right? Our 6 other different colors. Now that 1 is accounted for this spot, we have 5 options for here. Then we would have 4 options for here, 3 options, 2 options, 1 option. Now, because we require a first cube and a second cube and a third cube, we are going to multiply these numbers. So anytime we use the word and, we multiply. And we will continue to practice with this as we continue working with situations like this. So when I multiply all of those together, I will have 6 factorial. Now next, for my red and blue cubes, there are a few different spots where that red and blue cube can live. So that red and blue cube could be together here. They also could be in that spot instead, or maybe they're in this spot, or this spot. And in total, there are 7 different spots where they could live. 1, 2, 3, 4, 5, 6, 7. So that means we have to multiply the total number of ways by 7 because that pair of red-blue could be in 7 different spots. Next, we have to multiply by 2. And this is because we could have red-blue or we could have blue-red. Those are 2 different options because the order here really matters. Then I'm just going to put this into my calculator. So we will have 6 factorial multiplied by 7 multiplied by 2, which is 10,080. So that's how many ways we can have case 1. Now, in our conditions, we also wanted to see the situations in which blue is by green. So that's going to be our case 2. So blue cube beside green cube. And we approach it in the exact same way. We start by drawing our 8 spaces for our different cubes. 1, 2, 3, 4, 5, 6, 7, 8. And then we want green to be beside blue. Now, because I've used up 2 cubes, right, I've already accounted for their spots. I only have 6 other cubes to use. So 6 options for the third cube. Then I've already used that cube. So I only have 5 cubes left. 4 cubes, 3, 2, 1. Because I require a first cube and a second cube and a third cube and a fourth cube, etc., I multiply. And that will give me 6 factorial. Again, we need to account for all of the different spots where we can have the green-blue pair. This green-blue pair can hang out in this spot it's currently written in. I could also hang out here, 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 or here. So there are 7 different options of where that GB could be living. And then we need to account for the fact that we could also have BG. So we could have blue then green instead of green then blue. So we multiply by 2. And again, we multiply it and put in our calculator. So 6 factorial multiplied by 7 multiplied by 2 will give us 10,080. Okay. So now we have a very, very important step. Sometimes when we're looking at different cases, a particular situation occurs in both cases. So in this first case, I could have absolutely had a green here. In addition, I could also have red, blue, green accounted for down here. Because that possibility can happen, it means I've counted that situation twice. I've accidentally counted when blue is in between red and green 2 times. I counted for that in case 1 and I counted for that in case 2. This is called double counting, and we need to be very careful not to double count. So what we're going to do is we're going to figure out how many ways we can have blue right in between red and green and subtract that because we accidentally added it 2 times, so we'll just subtract one of those. So we'll call that case 3. Our blue between red and green. So again, we'll start the same way. 1, 2, 3, 4, 5, 6, 7, 8. Now this time we have blue in between red and green. And it doesn't matter here if I wrote green, blue, red or red, blue, green. Works the exact same way. So I have my blue in between my green and my red. And now here, because I've accounted for 3 cubes, for the 4th spot, I only have 5 other cubes to choose from, then 4 cubes, 3 cubes, 2 cubes, and 1 cube. Again, because I require a first cube and a second and a third and a fourth, etc., I multiply, and that will give me 5 factorial. Now we want to account for all of the different spots in which GBR could be. So, very similar to before, this GBR could be living here. It could also be living here. It could also be living here. And if I continue to put all of these boxes around all of the spots, we have 6 different spots where that could live. Now, the other piece that we need to account for is the different orders that we could have, right? I could have green, blue, red, or red, blue, green. Because of this, I multiply by 2 to account for the order the red and greens swapped. And then I put all this in my calculator. So 5 factorial multiplied by 6 multiplied by 2 will give us 1,440. Now let's figure out our total. So our number of ways, we have to first take all the ways red is by blue. So that was 10,080. Then we add all the ways where green was beside blue, 10,080. But in each of those cases, we accidentally counted case 3. So we have to subtract case 3 once, minus 1,440. Put that into our calculator, and we get 18,720 arrangements. And that is our final answer.